All right, hello. Welcome back. So last time we continued working on some pipeline issues, and there is still an issue with the there's an issue with the binding right now, because we kind of assume that the binding is supposed to be ran in a context, and context with a different standard in, standard out, and so on, standard error, and or actually standard in. I guess standard in could be. I guess standard in is inherited, but standard out and standard error is like they are. They need to be captured into memory, but it's only needed if we have like a process call or a function call or a block or something like that. So and in that case the pipes will get connected and eventually cleaned up, but if they don't, they are hanging there. So let's say we're trying to bind to a literal value that doesn't need the pipes. Well, then the pipes will simply get stuck and the process won't end. So my thinking is that, okay, well, we could hit two birds with one stone, and if we try to avoid compiling the pipe context, if it's not needed, then we get less instructions for the bindings, and we also avoid this issue. There could be other issues that we need to solve as well. For example, in a function call, it's not necessarily true that we need pipes. However, we could control that with automatically creating a pipe for the function that we clean up at the end of the function. So that can actually be solved. But for just any value that, I guess technically we could try to have like a cleanup thing happening or something with compile with context. I'm not sure, but anyway, what I did here is that I actually took help a little bit from AI here, and I asked AI to give a couple of suggestions as to how we could solve this issue, and I'm not sure if I actually gave any kind of suggestion to solve the issue, but the AI basically came up with two different suggestions. One was a pre-pass suggestion, which is the kind of sketch of that shown here. So we do like a pre-pass, we do like an analysis of the expression that is going to be compiled. So we'll do an analysis of that to understand, do you actually need a pipe context? And as you can see here, it's simply switching on the expression, checking, okay, do we have a call that we need to capture? Do we have a pipeline that we need to capture? Do we have a block we need to capture? And so on. An if statement is a little bit more complicated because we're looking at then and else. And I guess also it's like the if is actually kind of interesting, because if you have, let's say you have an if you have like an if and else, and only one of them needs a pipe context, then we still run into the same issue. If true, it goes into then, right? So if then needs pipes, then that's fine. But if else doesn't need pipes and you go into else, you still run into the same issue there. So we have to have like a cleanup thing for the pipes anyway, I guess. So this would solve most cases, and it would also solve like reducing the number of instructions that we need, reducing complexity in the debugger, or I mean the IR instructions generated. So that is very good. So we could still use this here. What was the other suggestion that the AI made here? Yeah, that was the first. Wait, what was the second one? Recommended direction. Wait, I'm pretty sure that I saw another. Okay, so did it disappear? Yeah, I'm not sure. I'm not sure where that went. I'm pretty sure it like gave a couple of suggestions on how to do it. I also came up with a solution, another solution here, that I gave it to like compare, which is like a more fundamental change in how we deal with stack variables, like local variables. But I realized that it's not as simple as just, because the idea was that right now we kind of calculate the relative stack counter for each newly created variable, depending on what the stack counter is at that moment. But the problem is, if we have conditional compilation, the stack counter is not always like up to date. With like it could be like instructions gets inserted, they get filtered out. So it's like we have to like, now I'm kind of manually changing that depending on what's happening. So so the idea here is that we, instead of having a relative stack counter directly when we define these refs, is that we have these symbolic IDs for the refs that will be like temporarily there, and then after we would analyze, we would do a step pass after the compilation to kind of assign the relative stack counter for each variable, basically. So but that was apparently well, in my mind that was like, well, it could be a more fundamental change that would solve a lot of these problems. However, the solution as far as AI was concerned was very complex to actually implement. So here it does like a comparison between the things. So here's the first suggestion here that we're actually gonna go with, I think, expression fx pre-pass. So we're doing a basic analysis of the expression to understand, do you need this context or not? And but it doesn't, but we still have some issues with, for example, the if statements. But anyway, so we have to solve that as well. And then the second solution here, suggestion, was transactional speculative compile. Now, I'm not entirely sure exactly what it means by this. Flexible for conditional emission and rewrites. Okay. Still, cons still depends on the current stack address model unless combined with more changes. So I'm not exactly sure what this means. I think maybe it's something with like you actually, I think this was maybe what I was thinking first, like you compile a thing that, and that thing then becomes not like finalized instructions as such, or it becomes like, it becomes kind of finalized instructions, a chunk of instructions, but it has like a relative stack counter kind of like a local relative stack counter maybe, or something like that, so that you can like insert it anywhere, and you would like adjust the relative stack counter based on where it's inserted or something like that. Yeah, I don't know. Well, anyway, and then this is my suggestion also, like we have this symbolic refs and post pass stack slot assignment. Yeah, so it says the process the best long-term architecture, decouples code gen order from final stack layout, avoids many manual hacks. So even AI agrees this would be the best long-term architecture solution. But okay, I see there's like missing text here. There should be cons here that says that it's very complex and you have to basically do a lot of things to make this actually work. And so if you look at, so then I was like, okay, well, could you explain about the complexity of the symbolic refs? Like, what do you mean? Well, what is the complexity here? And then it just, yeah, there's a lot of things here. So complexity mostly turning stack addressing. So if we sum this up, it says that short version, hard part is not replace counter with ID. Hard part is build correct stack effect with CFG compiler. I don't know what this stands for. CFG fix up engine. Yeah, so the hard part is basically, yeah, how do we correctly assign the stack values or things. So this is this is just necessary data model changes, so that's not really complex. New fix up pass, yeah, so we have to have a pass afterwards that would properly assign the stack things there. But then the issue is the control flow analysis. So straight line code is easy. Yes, I agree, because then you just have one thing that you do. Branches is worse because, well, we don't really use branches. We only use branches for if statements, for loops, and all that. And that is like highly, controlled. Context-free grammar. Hello, by the way. Oh yeah, maybe. I'm not sure. Anyway, it doesn't really matter. Maybe it's control flow. I don't know what it stands for, but it's basically the control flow is the issue here, because with no branching and no loops and no jumps, same thing. It's pretty easy to assign the things, but with it becomes. Oops. What the hell happened now? Okay, I just accidentally resized the window. But with this here, with branches and stuff, it becomes a lot more complex. Instruction, insertion, interactions, compiling insertions, instructions later, blah blah blah. Yeah, so there's a lot of things basically that needs to happen for this to work. And then I was like, okay, well, forget it. Let's just go with your recommended solution. Let's just go with show me like a sketch on, a starting point on how to do with this, because it's pretty simple here. It's basically you just get the expression and you analyze it to check like what expressions needs standard IO capture, and then we can just look at this result and see that, okay, well, if you require this, then we build in the pipes stuff. If you don't, then we don't. But as I said, there's an edge case in the if statement that makes it still hang. So that's not great. So we need to solve that issue as well. But I think this would be the best solution right now, because yeah, that's so I'm just gonna copy this because it's pretty simple to do, and then you basically just do this. Yeah, so that's fine. What is this now? Keep compile with context unchanged for now. Just use it conditionally. Okay. Yeah. Optional cleanup helper. Cleanup helper. Extract the existing capture flow. conservative first, refine later. Okay, whatever. I'm just gonna do this. So we'll go to the compiler and we'll add this function somewhere. Oops. Well, okay, I guess we'll add it in the actual compiler. Somewhere here. Pointless discard. Oh, interesting. Okay, so as you can see, AI is pretty good at actually generating zig. I'm not sure if it has updated to 0.14. I think it was running on like 0.13, or it outputs like 0.13 code. But this looks good, I think. I mean, it mostly is when you're dealing with types and well, comp time stuff basically, and IO stuff. But here is just normal stuff. Okay, so that is that. Wait, what about this thing? Well, this could be outside, so that's fine. Okay, so yeah, so this should suffice for now, and we can add more things later. I might actually force this to be everything. So I'm gonna say expression effects. Oh, expression effects, right. What did you actually say there? Nothing, okay. So identifier, yeah, there's a lot of these, so I'm gonna go to AST, expression. It's basically all of these. Whatever, let's just do else. We'll figure it out if something goes wrong. We have to add more things here later, but which model is that? There was Codex 5.3 medium. A ChatGPT Codex. I haven't tried Claude because I haven't. I've got stuck with Codex, so I'm used to using the tools they have. I think it's pretty good. I haven't really used like Cursor because I don't want to switch my editor. And also I haven't really investigated the price structure for the thing. Like I don't know. I have something against it. It feels bad when you have when you pay per token or whatever. It feels better to have a subscription based thing. I mean, I don't know. Maybe there is something for that in Claude. I haven't really looked at it, but I mean, Codex works really well for me right now. So I just used NBChat config with some tweaks. All right. Yeah, I mean that's a really good way to quickly get started. Are you using any kind of AI tools with that, or does that include anything, or yeah, the block always has a pipe, so that's fine. Actually, how does that work? Like if you have a block that doesn't actually output anything, will that also? Because then it doesn't actually connect. Okay, that does work. You tried Arch Linux a few days ago, it was good. By the way, Windows user. Alright. I actually installed like Arch Linux a long time ago because I was looking for like a minimalist. I was searching like I wanted like a minimalist Linux, and Arch came up. And I mean, yeah, I don't know. I'm not that much into different distributions and stuff like that. Copilot sometimes. I have a GitHub student pack, so I get amounts of free talks. Oh, cool. Using it since 2023. Okay, man, time really changes now with AI for new people. More stable than Fedora. What makes me not wanna like switch to Linux? I mean, there's a couple of reasons, like gaming, for example. I don't. I mean, yeah, I wanna have Windows for games. It's basically also whenever you kind of wanna install something, or like it's just the stability of things. Like WSL works. I feel like almost WSL works like it's more stable than going from scratch. I don't know or like Linux as a native operating system. Just in my experience, just in my personal experience, I might be doing something wrong, but it just feels like sometimes things just fail, and you have to go on a wild goose chase to figure it out. I see. Now I'm vibe coding and auto content creation and posting software using Tray AI. All right, does it work great? I haven't heard about Tray AI. Are you using an NVIM distro or just native with plugins? I just installed NeoVim and made my own config. I spent like a weekend on just looking for plugins that felt absolutely necessary for me. I wanted like a very lightweight config, and yeah, so I just searched for a bunch of things. I created my setup, and that's it. I haven't used any, lazy config or anything like that. I agree. Claude Code burns tokens so fast compared to subscription models, but I think results outperform so long. Okay. Well, I've heard that Claude Code is like the best right now, so I'm curious to test it, but I just want. Yeah, I already have subscription for GPT, so that's why I'm using this for free, basically. I mean, Windows just fails at random things, and I don't want to Docker desktop taking 10%. Yeah, I don't have Docker anymore either. Docker desktop. Docker desktop. Yeah. I mean, I don't think you have to have Docker desktop for WSL. I don't think so. Windows new bugs are driving me crazy. Wi-Fi disappears. Yeah. Okay. Well, different. Well, I'm not using Docker Desktop for WSL, and yeah, that's it. It's just that in Linux it feels like sometimes you want to install like a program, you want to install like some kind of package or library or whatever, and it just fails in some weird way, and you're trapped in this giant mess of different config layers, and it's like, okay, where do you even begin to try and solve this issue? It's like you have to kind of study the whole thing from the bottom up to understand how to solve one issue. That's what I have. But maybe, yeah, that was my experience. I haven't tried Linux in some years, so Docker is in your workflow does not run well when Windows. Okay. I was putting whole Python here. LLMs. All right. I would say this. I did mess around with adding voice support for codecs in the terminal, so I can start a codex as I can start a script that runs codecs and it looks at the output, because codecs actually it outputs like a JSON log of what's happening, like events. So you can basically also create your own app that works with codecs. I'm not sure if you have to use like codecs exec for that, but which is basically like a CLI version. But I'm using a 2E version of codecs, and then I have like a watcher that watches for changes in the JSON logs, and when it receives a result event, that basically is that the codex is done with the task and it gives you a summary of what happened. Then it reads it out in with Piper. That was kind of fun doing that, and I did that with the help of AI, of course. With codecs, you are stuck with OpenAI models, but you can change which OpenAI model you're using. So here we have like model, and you can choose. There's different codecs models. Yeah, I guess there's not much to choose, but you can choose like the model, and then there's different reasoning levels, but they burn more tokens. All right, so let's just test this out here. So we have compile binding, and here's the part we need to worry about. So let's do an analysis. And we have the expression is going to be this expression here. Oops. All right, so that analyzes the thing, and we get expressions out. And then we can check here if, let's remove this to do. If we require capture, we do all this crap. Otherwise, we do something else. We need a result. Now, this part, oh, I guess this is part of it as well. Is this also part of it? No. Actually, let's take that in there as well. Results. All right, otherwise, I think we don't really do much of anything. I think it's just we compile result equals compile expression, and that's it. Expected if expression. Oops. Okay, so what's happening here? Expression. We have an else branch. If expression. I mean, really, we won't like to put it back in here, actually. So we should break this out into its own function, actually. So analyze if expression effects. Oops. Expression effects. It's just whisper and convert. Yeah, I did try that, but I haven't gotten it to work, and I don't want to spend too much time on it. But it would be cool if I could walk around, tell Codex, like walk around with my headset, tell Codex to do something, and then it would give me an update through voice, and then I could like tell it to continue with something else. You should give Claude Code a go eventually and plug in Kimi K2.5 or GLM. The APIs are dirt cheap. $2 per 1 million token output. Okay. They have better benchmarks all open API models. Open AI models. Oh, cool. Yeah, thank you for the tip. I'll probably do it sometime. It just takes a little bit to to change your workflow and all that. So I mean, I am interested in trying to see like what Cursor could do, because the thing about Cursor is like it seems like a very nice tool, because it could work with any model basically. It seems like, and but I would want that version, but not in like its own IDE, but I would like it to be some kind of just like the Codex 2e or something that can integrate with other editors, not like its own editor. So that I can integrate it into NeoVim, for example. Or just run it in a separate like terminal window or something. Or using AI now to do work. I mean, I think this is the first time I used AI in this project since I stopped using it at the start when I first like jump started the project. There's a little bit of history there, but I do use AI for other projects that I don't really want to spend much time like programming myself. I just want to test something out, and also test, you know, AI. What is AI capable of doing? To keep myself in the loop of, you know, how to use it and all that. Because I think it's probably gonna be necessary to use because of the potential productivity boost it could give you as a developer. So I think maybe in the future companies would actually require you to know how to use AI tools. I don't know, but we'll see. But it feels like it could go that way, so it's good to do it anyway. Because you know, it could help with productivity. It does help, like, to give you some perspective. Like, it could give you knowledge about things you don't know. Like, you could ask it questions, even if you don't want to use it to program for you. You can still use it to get some, to quickly ask a question or quickly say, like, could you investigate this code to find where this is happening or whatever, and it could give you an answer. And then you can do something else in the meantime, basically. So Claude Code is TUI, but you can plug in any model, but then you're forced to use APIs. Okay, so Claude Code also has a TUI. I didn't know that. Cool. Alright, so that one is that, and then this one will be if expression. Okay. And now all of this will be that. Okay, let's just not have it as a pointer. It doesn't really make sense. We're just analyzing, we're not modifying it. All right. Cool. So we have this basic thing. Now, as I said, the if expression still has a bug, so I'm gonna add a to-do here. There is a bug here if one of the branches does need standard IO capture, but the other branch does not. And if we go into, and if the runtime goes into one of the branches that does not require captures, then it would hang because the pipes are not cleaned up properly. So maybe even have the pipes. No, I don't know. Yeah, this is a problem we need to fix, but let's just have it like this for now. All right, so with this, yeah, with this here, it's gonna be like we have expression effects. If we need a capture, we do all the piping and stuff and compile with context. I guess this part should still be the same, although technically it couldn't be this type. Well, actually it could still be this type because no, it couldn't be this type actually. This type is only for like internal, yeah. If you execute a process directly, with the binding, like const b equals echo hello. Then you would get this as a result, but then it's transformed into this type here, which is the result struct type instead. So you can, so this is what you could get instead. But otherwise we just compiled it as normal here. Okay, cool. Now we could use this analysis for other things as well, like the no, maybe not. Okay, so let's do like bindings basic, and okay, interesting. Let's see what this compiles to. Oh, access unified location while value is active. Is this in the analysis? Compile identifier binding. Result source dereference. Wait, where is that happening? Compile binding 1013 here, right? So it's this part. This one is saying that it's a pointer, except it's not a pointer if we're here. So it's like, well, an easy solution would just be to do this. And then we don't need two different results. Or I mean, we don't need to have this as a variable. Up here, there we go. Okay, now we get this. So now, yeah, I think line 1 doesn't even have a compilation now. It doesn't even have instructions. Because we can see here, like compile binding, it doesn't output any instructions. These are all comments. All right, so if we run this, this now works, great. But if we have like an if true, and let's say this requires a pipe, so I'll do like echo this is from then, and then we have else I don't know, else nothing is happening here. This is just a literal. Okay, so if we run this, it should work, I think, yeah. However, if we do else or false here, I think this will hang now. Or not, okay? What the hell? Okay, never mind. Maybe, I mean, there might be a race condition. There might be a race condition or something here, or I'm missing something maybe. No, because this is not conditionally. Oh yeah, I have to bind it. That's right. So X is this. But I think technically we need this to be the same type. Hello, Joe. What's up? Hello, stranger. And then I guess we can try and echo this. Okay, now it hangs. Yeah, but it's still echoing the thing. But if we set it to true, it should not hang. Okay, yes. So there you go. If we say false, it's hanging because of the issue that I said. And this is because it's happening in a binding context. So basically what we're doing is we're trying to analyze if this requires pipes hookup or not. And since we have an echo here, it does. However, it's only this branch. So if we go into this branch, the pipes will get stuck because we don't have anything cleaning them up. So that's the issue. We need something that cleans the pipes. Yeah. I'm gonna add a to-do here. We need something that cleans up the pipes, because otherwise they will get stuck if they are not used. You put an echo and not echo, yes. So this is just a string literal, and this is, you know, it's echo. So if false, it would assign x to this literal here. If it's true, it would assign x to the result of this. And the return type of this, it's like in Bash, a function doesn't really, I mean, it has a more complex return type, because essentially functions have like, or executables and functions are like, have like two different return types. It has the exit code and also the output of it. Basically, it almost has like three different outputs. I mean, you could technically call the exit code the return type. And then but then you have a bunch of side effects, because this is outputting to standard out, right? Except it's not, because it's captured and put into memory because we're binding to X. So if we didn't output X down here, we wouldn't see this echo into standard out. But basically what I'm trying to say is that you can sort of see this as the output of echo is standard out, right? Or it could be standard error as well. That's like two different outputs. But you could also call, like, generalize it, just call it files or pipes. So a function or a process would have the exit code as the return type, or return value, but then and then a bunch of files outputs. So but also it's like you can, when you pipe something, it automatically picks standard out, right? It automatically picks standard out from echo, from this, and puts it into standard in from here. So those are special. And also you have like redirects as well. But yeah, it's just if else with print statements. Yeah, I mean, technically, I mean, if you just look at this like abstractly, it's not really that mystical. If you compare this to Bash, I think you would kind of get the same thing. Like if you do this in Bash, wait, no, that's not correct. No, it's tail. No, what is it actually? Tail. How do you get like without the expression, or I mean extension? What is R? R, okay. There we go. But I want, oops. Okay, there we go. Just practicing a little bit of Vim there. Okay, so basically you have s equals, I think you have to this is also, you have to have the equal sign, like this is different. You can't have spaces here, I think. So you have to have like this. I love pointing out these weird things with bash, by the way, because I'm trying to replace it. Well, not everything with bash, but basically here, and then you do this. Okay, so if you run this, bash, you get hello world. Okay, good. And then we have like x equals, actually, how is this even possible? This is, I'm not sure if we can, well, I mean, yeah, I guess we can have this. This could be any expression, I think. You could even do this, I think. I'm not even I'm not sure. You probably have to do this. Let's just do this anyway. So if is it like this? True. Then echo this is from then. Else. Is that correct? Need a space. Okay. Okay. Yeah. And then we echo x. Yeah. So you can see that this is the same. It does the same thing, basically. And then we have a false. Command not found. Okay, so so actually, well, it's a difference here because you can't just. I guess you can't have this as a thing that this expression results to, because it's trying to run this, I guess, as a command. Maybe. Is that not even? Is that not possible? Like you can't have an expression like this. You have to echo it out. Okay, I'm not sure if you can do the same thing. There's probably a way to do it. I mean, with bash you can do a lot of things, but yeah, I'm not a bash guru, so I don't really know. But this is apparently it's not possible to do this specific thing, because it's trying to run this string as a command, and of course that's not a thing. But anyway, that is the case. But the thing is also like, my language is gonna be like, I haven't decided yet, okay? But my initial thought that it's actually gonna be, you know, it's gonna be strongly typed. So if we just type this into a string, then this is actually gonna be, I mean, I think this is just gonna be coerced into the string. But really what's happening is right now is that the result of this is stored in kind of like a struct where you have standard out, you have standard err, and I also have exit code. So you can access all of those. Like if we, let's say we run this again. No. We run it. Okay. We get this x. This is from then. What was I trying to do? Yeah, but if you say it's .standard out, it doesn't work because we haven't supported it yet. Okay, but the idea is that you could say .standard out to get standard out as well, or you can say .standard err to get the standard err, or you can say like exit code or something like this to get the exit code. And you can also, if you use, it depends also if you use it in a different context. Like if you use like and true, this would be coerced into a Boolean value, which we really don't have Booleans in Runic actually, or Bash. It actually is an exit code. And that means that true is 1, or I mean, sorry, true is 0, and false is 1. Because if an exit produces an exit code of 0, that means success, that means true. Hello, Metallics, welcome back. And if it produces like a 1 or something else, that means it's an error, right? So that means false. So this would coerce it into a kind of like an exit code value, right? But this coerces it into, and then the exit value is coerced into a string because of the string interpolation. But this would coerce it into a string, and when a process result or an execution result is turned into a string, we automatically pick standard out. And I think Bash does the same thing. Let's see, if you say like echo and then you have some kind of flag that doesn't exist, I'm not sure. Wait, how do you? Okay. Does it have flags? Display short option, long option. Maybe if we say like echo E. I'm trying to make echo fail, and then we have like some garbage thing there. No, it still works. Okay. I don't know. I don't know how to make echo, but grep has, you know, you can do this, and then it will become an error. You can see the exit code is 2 for this, so that will be false, right? And also, this is, you know, the 2 means standard error. So if we put that to dev null, we don't get any output. If we put standard out to null, we get this output. And what I'm trying to do is I'm trying to say x equals grep. I have the exact same thing. Okay, so that is that. And then echo x. Oh, we still get the thing. Okay, so it god damn it. So it actually shows the standard error. Okay, so I guess it concatenates both of them. It merges the output. What if we do like what if we do no? Yeah, okay. So okay, so it actually merges the thing. So we should add this to the to-do. Where would this be? I guess maybe, I don't know, let's just add it as a bug. So coercion of execution result to a string needs to have both standard out and standard error merged. And I believe we should probably have a separate pipe for that, maybe, or a separate like buffer for that. I don't know. Maybe not. Maybe automatically, or maybe it should only be when it's like bound. When binding or coercing directly in a string interpolation. Because we still want to be able to redirect and stuff. Alright. Anyway. It's good to test these things. But okay. So yeah. So this tested our hypothesis that if we put this to false, this would hang now because of this bug here that we have. So, and the reason for that is because we have when we bind something to a variable, we don't want it to output to standard out. We want to capture the output, and then if we do that, we create these pipes. And then the pipes have to be used. If they are not used, they get stuck. So we need some kind of mechanism to make them unstuck, or make them be used. The problem is that there's some async things going on, so we're not entirely sure about the timing of that. Like, when could we deem them be when would they be unlocked, so to speak? We could maybe have some kind of nested locking variable that when it's set to true, that we would continuously check, and when it's set to true, we would then unlock these pipes, or not unlock, but we would like clean up the pipes, something like that, maybe. I'll add that as a suggestion here. Maybe we can have a nested variable structure for inner threads that will set to true when the thread is done processing. We can then continuously check that variable from the outermost scope here, and whenever it is set to true, we would set the pipes to be closed. Yeah, something like that, anyway. Okay, but I'm probably not gonna work on that now. But yeah, we actually have this sort of working. This use case does not work, but I'm just gonna do this. This does not work yet. Check compiler at what else do we want to look at? Maybe blocks. I'm still surprised this... Well, okay, actually, you know what? This should also hang. Yeah. For the same reason. So this hangs. I'm gonna move that to here as well. Same as above. And the reason why it hangs is basically because we're marking blocks as needing pipes context. However, this is kind of interesting because the block actually produces a pipe itself. So maybe in case of blocks, we can just use that. No, but because that's connected to the inherited. Yeah, we need a context. No, yeah. Okay. Blocks. Yeah, but here's a sample block. Let's see if this works now, actually. Yeah, okay, so this actually does work now. And it's streaming, as you can see. We're streaming this out to grep. So we're filtering out these somethings, we get the hellos, and then we have a tail F server log, which actually hangs. But we still get output here, because it reads from server log, it outputs it, we're streaming it to grep. And then, we never get here, because we're stuck here now. But if we remove... if we interrupt, we get if we remove standard in. No, it's still... Well, standard in doesn't care about... Tail doesn't care about standard in, I don't think. Okay. But anyway, that's cool. You can also do, like, if you do cat, because I think that will read from standard in. So you read from standard in. I just typed out hello. I think we don't show anything because it goes into grep. But if I press Ctrl D, I close standard in. No? Okay, that didn't work. I'm not sure why that didn't work. Okay, D, enter. No? Okay. I don't know. But anyway, I wonder if that works on Bash, actually. Okay, so that actually shows the cat, interestingly. Okay. And then if we close input, okay, that actually does work. There's some discrepancies here. Cat does not echo, or, yeah. Well, cat does not echo the input until we press enter to make grep echo out things containing hello. In bash, this actually echoes the input. Also, Control D does not work in Unix, but it does work in Bash. Interesting. Okay. Some, quirks. I mean, it's probably, I mean, this is probably not a bug that I would consider MVP, really. It depends on... what I'm gonna do is to determine if we have like MVP or not is like... I'm gonna make a script. Like we have the MVP script right now. And when this is when everything in this file works, I would consider the first version of the language complete. It's not fully done yet, so I still have to do some function stuff, and maybe I need to figure out, okay, what do I actually need for my scripts to be able to use them properly? Perhaps like process, being able to like kill processes, like getting process IDs from executions and stuff like that as well, because we don't actually have that right now. Or well, I mean, we technically we could have it, but we don't really. It's not like supported right now. But yeah. So that's the plan. Okay, but what do we want to do now, though? Yeah, because I think I've done like, yeah, does not really act on standard in. Cat grep hello. Actually, this might be related. Okay, so it does work, except it just doesn't output anything until I pressed hello and then enter. How cat write that you type out without being grepped? Yeah, that's the thing also. Like it's kind of weird that the bash version here actually does output things that like output the things into cat. Like I can type now and it will show it, which is kind of weird because it's supposed to be piped into grep, but maybe it's like a different mode. Because in the terminal there is a mode you can set for echoing out the input. But maybe that's maybe we have like raw mode, and this I think echo false. Maybe we just set this to true. Do we always do this? I think we do. And you can say man, what the hell was it now? Is it just I thought it was something else. Oh, I see. So we just need echo. We just need this. But I don't want to mess up something else. Bad file descriptor. What the hell? Okay, what if we don't actually do raw mode? Because I think this is for the debugger. So what if we just don't do this? Oh, got some errors. What the hell? One second. Let me Google this real quick. Standard in bad file descriptor. I mean, we are using like a custom. We are creating like. Wait, or no? I think we're just using the inherited standard in. I think. Bad file descriptor. Hang on. What are you actually doing? We're creating this. No, we're just looking at it. And then we have standard in. Yeah, I don't know. Okay, that's weird because it was working like when we were in raw mode. But this was, yeah, so this worked for some reason. What the hell? Okay, so it now all of a sudden it refuses to work. What the hell? Okay, I restored this file completely. Oh, wait. Enable IR. Okay. Wait, but now... Yeah, Control D does not work. And if we go back to this, wait, do we have errors? No. I just want to make sure. Okay, we don't get double output. We don't do raw mode. Oops. Build. Now we get double. No, okay, so now it's like, you know, like bash. Close. Yeah, Control D does not work. Because Control D should it closes standard in. Yeah, okay. Already is you get EOF. I thought what it did was close standard in. I mean, I might have set some flag that makes it not do... Well, actually, no, because I didn't enable raw mode now. So I'm just reading. Okay, so maybe we actually need to implement that. But how does cat actually look at that to close standard in? I thought bash would do it like... Like Control C is not something that I implement. Is automatically sending an interrupt signal, and then we look at we actually trap that signal in Runic, but we don't look for if the user presses Control C. So I would assume that Control D was also coming from the same place. But maybe it's not. Maybe that's different. Okay. So does Control D send a signal? Does not actually send any signals. There are other terminal key combinations that do. Control. Oh, okay. Control D. Okay. Okay, I'll just write this down then. I'll just write it down as something we need to support. So support Control D for closing standard in. All right. Okay. And then also, like, now we don't enable raw mode by default. However, I would like to enable raw mode if we're in the debugger, because then we need raw mode. So let's see. And that we know after we get the config here. So I guess we will check here if we want to debug, then we enable raw mode. Okay. Hello, Moopen. Thank you. Welcome. Are you a developer as well? All right, so now let's test that. So we'll do. Okay, yeah, that works. And then we'll do debug. That looks like it doesn't really work. Maybe it's the terminal in no? Okay, so this has changed. Oh, I see. The defer is happening straight away because we're in this if scope here. Yeah, so that doesn't work. Okay. I think what we'll do. I mean, I was thinking the easiest is to put a variable in here, a boolean, and that way we could move this out like this, and we would then so this would be a bool that says that, okay, should we enable or not? And this would also, I guess, if, and I guess this would be like null. We could also do like if this, then we do this, otherwise null. Okay. There we go. Okay, cool. Yeah, so now we have the debugger working here. I mean, it's not perfect. But at least the two different modes should work now. And if we don't debug, we get this. Okay, cool. Cybersecurity enthusiasts and the students. Okay, cool. Well, welcome. Is that why the bash keyword caught your eye? Or your interest? Maybe, perhaps. All right. Yeah, I'm just exploring it. So, what could we take next that... Okay, well, I guess we could say this works now. And this, we actually have this now. This works, yeah, but there's bugs with it. I guess, I mean, okay, for loops is interesting because we don't have it in the IR yet. I think this is this could be a huge thing because of how we want the iterators to work. So basically, we need like array iterators. So I already implemented this in the previous version, and the way we did it there was basically we had a generic iterator interface, but this is all in Zig, so it was way easier to do it there. So a generic iterator interface that could be one of these iterators that we would support. So it would be an array iterator, it would be a range iterator, a range iterator, sorry. And every other type of iterator that you could add here to support. And then we'd have a generic iterator that we would use to be able to talk about this in a generic way. And then we would have also like a runtime struct kind of thing for managing an actual iteration machine. That would get the sources and iterate over them. Now we have to make that whole thing in IR. So yeah, it could be a lot of things. It could also be super simple for some things, like the range iterator is probably pretty simple. I mean, to be honest, the array iterators could be very simple as well. But yeah, it's potentially something that could take like a while to do. So I'm not sure if I want to start with that right now. I just want to see what else we can do here. We have like the these things, the binary operators for and or, which is nice. We could start with being able to like coerce execution results into, you know, into exit codes or booleans, sort of. Redirections is not something that we will do right now. That's probably like a huge thing. I won't deal with that right now. Error handling, no, because error handling is okay. Because I want Runic to feel like Zig, except it's Bash. So it's like a mix between Bash and Zig. So we're gonna have like, you know, the optional types, the error union types, and all that. So that's how I want the error handling to be. It's like errors. Yeah, we'll see, because right now I'm just right now it feels like I'm just remaking Bash with different syntax for like if and loops and expressions and stuff and bindings. Of course, we have function calls, function declarations, arguments is something we really want to have, of course. We should be able to maybe it's not. I'm actually gonna investigate that. So let's try and go. So here's a function test. So let's just see if this works. Okay, this doesn't even work. Could not dereference location of type data. Unsupported dereference value type. Okay, let's see where this goes wrong. So it does compile, but there's some issue with here. Set. So for f, set that plus 0 to C. Okay, so for f, let's look at that. So r plus 0, so r is a heap pointer now, so we look at the heap and there's a bunch of voids. So we're trying to set this to C plus 1, and what is, no, C plus 0. So what is C plus 0? C is at 0, so that's actually an invalid closure pointer, like a heap pointer. So why do we have an invalid pointer? I mean, it could be that our function compiler is out of date. So I'll look at this. Compile function call, probably. Okay. Well, here's the issue. So in short, you are making a language that looks like Bash, but also better than Bash, right? I mean, I wouldn't call it better, because Bash has like a ton of features. Like it has like infinite amount of features, and they're still coming out with new things. So I would describe this more like my personal like toy language that I want to use instead of Bash, because I don't want to have to constantly look up Bash syntax. So that's why I'm making this. I'm trying to make like a Bash, a simple Bash language that is more like, that is easier to like use and maybe even reason about. We'll see. But that's the goal. Like, it's not supposed to replace everything that Bash is doing, because Bash is like can do a lot of things that Runic can't, and it probably never gonna be supporting. But you know, we'll see. Right now, I'm just trying to make the MVP. I'm just trying to make the first version that I would like to have. So, and the way that I decide on that is basically, you know, the way that I would say we have a first version is basically, do we implement all the features that I would like to be able to use, so that it could be a useful language for me, for my personal like scripts. Okay, so yes, we need more crazy people. Thank you, I guess. Yeah, but it's fun. It's a fun project. It's really fun to do the IR stuff because I've never done that before, and it's incredible when you get down to it and how complex things can get. It's just such a different world than the normal kind of programming things you're doing. Like making a language is definitely not the same as using it. I mean, that sounds obvious in a way, but you know, because you're thinking like it's just programming, right? But it's like it's so different. I mean, I might be, you know, I'm not that well versed in making languages, so you know, I might be doing things very inefficiently and stupidly, but I don't know. But yeah, I'm making progress, and yeah, it's fun. Okay, so yeah, the issue with the function calls is that we don't have the closure there, and actually I'm not sure why we would need it for this one, because this doesn't really use any variables, so that I'm curious as to why we get this here. Like, why are you saying that we would need closures? That's the thing. Maybe it's like the forced closure of each echo. Okay, yeah. So we have this block here. That's right. And here we're setting like 4 different closure variables. I suppose those are for the echo. I think that's for the echo. So this is the interesting thing, is like, do we even, I mean, we don't need this. So this is gonna be, you know, compile. So basically, it's like you go into block, compile block, and then we have a bunch of statements in the block. And they are here, yeah. So each statement here which are the bunch of echoes. Then you go in here, and then you have a bunch of expressions, and these expressions are call expressions. And then we compile the callee, we compile that expression. All of those callees are identifiers, so that goes into the identifier compilation. And basically the identifier compilation is basically checking, okay, do we have this identifier in the scope? So do we have something in the scope? And it shouldn't be in the scope, so we should get an executable and return that, and that should be the end of it. But for some reason we're declaring a closure variable, and I'm not sure why, because this should turn up false, and we should just return this as an executable here. And then the callee would go in here and it would check, okay, well, you're an executable, so let's compile executable call. So let's look at here, we're looking at the compilation and see what's gonna happen. So we have statement, expression, function, declaration, okay. So that's the declaration, fine. Then we have the next statement, which is the function call, I think. Maybe? No, okay, so it's actually compiling the function. Right, so it's compiling the function now in the declaration, right? Right. Yeah, blah, 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 blah. Where's the compile? Okay, so I'm gonna look for compile function call. What? You're also on a project right now making all-in-one pen test tool more stealthier and less complicated. Okay, I'm not sure what that is. I'm not that big into security, sorry. What's Hatton, Captain? Yeah, what's happening? Oh shit, it's the Minister of Defense. Okay. Yeah, what's happening? I'm trying to figure out. Wait, did I not add this to the thing? Function call. Oh, you don't have a comment. Comment. Alright, there we go. Okay, now we have a function call. So, yeah, that's it. It doesn't actually do much here. Okay, I guess that's not what we were looking for. This is the function call. It just forks into the function. And then we wait for that. So that's fine. But the function thing is, well, this is the block. We compile this. This block, it should be compiled somewhere over here then. I'm trying to figure out why we get this error. Here's a bunch of these. So for some reason we need a bunch of closures. Now this is happening in set number 4. Compile block. Compile identifier. Executable call. Because obviously we get 4 different. Hello. Compile executable call. Compile identifier binding. Execution handler. Oh. Oh right, so it's the okay. I think it's the variable, the variables, like we're storing like the results, even though we're not really binding these to anything. The results are still stored in like a variable. It's because we're not optimizing that away. I think what we need to do is we need to fork this with the closure. So let's go to the function call here, and before the fork, let's just go to compile create closure. Yeah, it's just gonna be this here. So this will be the closure. Okay, and then we have the fork, and we already have the set that we're going into. So we simply need to call closure initialization. Do you get anything now? And I think that's it. Do you add anything else? No? Alright, cool. Does it work now? No. Still get the same issue, I guess, or maybe. Yeah. Still, the closure is not defined. Oh, wait. I forgot about this. So actually, yeah, okay, so here's the closure. We need to pass in closure ref, yeah. Dereference. There we go. There we go. Now we work. Now it's working. It's a tool can scan and find flaws and bugs on website or more. Oh, okay. Nice. Awesome. Now website side I am familiar with. Maybe not so much the cybersecurity stuff because I don't know. That's not my cup of tea, but I am a web developer of some years, so that I am familiar with. Okay, so that works, and we can call this however many times we want. Yes, very good, very good. Can we pipe it? I don't think so. I don't think we can, because we haven't supported that. Wait, we have a leak. What? Yeah, okay. So we have a leak and it says unsupported expression. Yeah. Would be cool to get that working. Maybe that's what we want to do. Be able to pipe. What can we do to make that work? Compile pipeline. So here's a bunch of pipes. Wait, unsupported expression, was that the thing? Okay. So I'm pretty sure what we get function call, we get the handle. Now I guess the function call, we need like like we don't have a type for that. I mean, this should be a thread type though. This should return a thread type. Yeah. So that should actually work. And then you are a call. And then we just return that. So I'm not sure why that doesn't work. It should be waitable because we're looking at the function call result. It's a location and the type is thread type. So why does that not work? Maybe we can... No, it doesn't even compile. And unfortunately, we don't really have the trace. We don't have a trace for the compilers, but I'm pretty sure we get here, and it says that, hey, you're not waitable, so it's unsupported. Yeah. Hello, Penguin. Welcome back. I'm just gonna refill my coffee. I'll be right back. All right. Okay. Okay, so, okay, let's start by logging here a little bit. I want to log this. Are we here? We are definitely not here. Here we are. Question mark. Are we here? Here we are. Okay, so we are there. So that's where we are. This is where we are, and that's why we get an error. Okay. So my analysis was correct. Okay, so why is this not waitable? I'm just gonna do this. See what we get out. Source location. Okay, let's look at. So it's a location. Let's. Well, actually. Let's look at the type expression. Does question mark any work? I guess it does. Void. Okay, interesting. So for some reason it's void. So I'm pretty sure this would be like an identifier or a call. Actually, let's look at the enable I or verbose. No. Actually, no. Print AST. So we have a statement at the end. We have a pipeline. We have a call. Call is the identifier hello. And then and then that is looked up, and we simply return, you know, the binding result. That should be typed. Maybe function declaration is wrong, because this is okay. What is all this? Maybe there's some issue here. I think the issue is that when we declare, we don't declare it properly. Maybe. Figure out how to be able to call async functions multiple times. I think we've done this actually. Okay, I'll let this be here for now, because this I'm not dealing with async functions right now. So we compile the body. That's in the results. Yeah. And we also wait for it. Sure. No closure, because the closure needs to be created for each function call. Wait. No, it does not. Actually, the closure needs to happen here, right? No, wait. How does this work? Well, we need to know the variables, the closure variables we need in this function. So actually, we need to surround this thing with a closure. Yeah, maybe that's the issue. Okay, I need to think about this a little bit. But anyway, let's see if the problem at hand here. We have this function reference. So the declaration actually has a function reference. Which is a value, it's a function reference value. Okay. So we have a call. And then the call is a function reference here, and we compile the function call. And that is the result of this call. which should be this handle, which should be a fork, which should be a thread type. So I don't understand how it loses that information here. Compile expression. Okay, let's try. We go to pipeline. Yeah, I don't know. Okay, let's do expression. Call. Okay. Let's do call poly identifier. Oh. Okay. So expression is a call. We go in here. The callee is an identifier. It gets turned into a function ref. We return this. The result of this we return. We get the fork inherit result that's just returned. I don't understand. Compile function call. Handle type. It's a thread. Okay. And this is the location. And this simply wraps it like this. We're using all the information we get here, right? So we shouldn't lose anything. So what the hell? And then this should be returned directly. And then this is returned. So what the what? Yeah, I am confused. Compiling call. Compiling function call. Oh, we don't have the name here. Okay, fine. Wait. Wait, what's this? What's happening here? So this is a call. I'm just gonna do this. Compiling this. Call the identifier name. Let's do lookup. Stage expression, lookup hello, source, result, source, okay. Source value, we need to look up, well, it's gonna exist, so I'm gonna do this, result, source, value, and I'm pretty sure it's gonna be a function ref, but let's do that. Yeah, it's a function ref. What the hell, man? Compile call. Callee. Should be a function ref. Lookup. It's a identifier compilation. We should get a function ref. So that should be a function. Okay, I mean, it would be easier. This would be an ideal situation where you would want to use a debugger in Zig, but I haven't set that up to work well with with like NeoVim. I'm not sure how you actually do it. Maybe I should look it up. Zig debug terminal. LLDB. That it just. I'm just no. No, I'm not gonna go there. Okay. Well, okay, so it's gonna find it. So we have the source. Okay, so I looked at this a little bit wrong. We're gonna find it here, right? So we get the source binding. Then we are finding it in our shallow scope because it's defined in kind of the global or the outermost scope. And that's where we're trying to call it as well, I think. Or maybe we're not. Well, anyway, we should find the binding anyway. And it is it mutable? No, it's not. Hello. Sorry, I can't pronounce your name, but welcome. Beginning with MFANA. Kagama. Welcome to the madness. What am I even looking for? Look up hello. Okay, yeah, I didn't include the information about the mutability. So let's do this. Mutable is false, so it's not mutable. Okay, let's go back. Oops, identifier. So it's not mutable, which should mean we're going in here. Excuse me. All right. You would like to see this language syntax? Okay, 1 second. I just want to finish this thought here. Okay, returning local binding function. Okay. Function call. Compiling stage expression lookup hello. Compiling call are we? Sorry, it's just skipping this whole thing. Okay. Anyway, yeah. So here is the syntax, sort of like an example file of all the features that are currently working? Well, it's working with the current version. I'm working on a new version right now, but this is like the current version working here. So so yeah, I mean, it's basically like Bash. You can see here you have these basic like Bash expressions, and you have pipelines here as well. Now redirections or conditionals are not implemented yet, but they are definitely part of MVP, I would say. And then we have, you know, if blocks look like this. So I guess, you know, if you compare it to Bash, it looks a little bit more like a programming language you would be used to, like C or something. If you're a programmer that has worked with C, I guess. But yeah, that's the whole point of this, is basically to make a version of Bash while not having all the features of Bash, but essentially the features that I personally would like to have in order to make whatever I want to make. But this is the syntax here. For loops is zig style. So you have, you know, this is a range, and you capture the element, and then you can use it in here. The functions. So functions are kind of weird. They are not like finalized yet. But this is like a draft here, you could say. So basically, it's going to be typed language as well. So at least that's the idea. And so this is a language that basically the idea is that this would be the standard in type, and this is the standard out type, and then this is parameters. Looks cool, by the way. Yeah, thanks. And so hello, this is a function called hello, and it's basically, you know, trying to mix Bash with Zig syntax, basically. So this is kind of like a Zig syntax, except the types. This is return type, so this adheres to Zig syntax, and this as well, if I'm not mistaken. Yeah, this is the only weird part. It's like standard in type. It's like you have a new special kind of type that denotes whatever, you know, standard in we want to have in this function. And since the only thing we're doing is calling echo here, which doesn't really take standard in, this is void. So yeah, and then you can just call it like a normal executable. So right here. But it's not gonna be its own shell or anything like that. It's just a scripting language that runs these things in a script. So it's the main purpose is just to make it easier to write scripts for me personally, like Bash-like scripts, and also to make a language, because that's a fun project for me. Yeah, and so here you have, like, you know, creating variables, which looks exactly the same as in Zig, where you can have constant variables that doesn't change. You can have mutable variables with the var keyword. This can change, you know. So if you try to change this, it's going to be a compiler error and not a runtime error. That's also important to note. It's going to be like, you know, it's going to be a static analysis that will analyze the types and also the correctness of the program before it's run. So it's not like Bash, where it's just running it, and then when you encounter an error, it will like panic out. Removing FM makes it a bit better, but I like it though. Yeah, I think it's just to adhere to the zig-like syntax. But also it's also like a marker to see that, okay, well, now we have a function coming here, so it's easier to parse for the compiler as well, or for the parser. But I'm not sure if we remove this, if we could do it, but this is basically a keyword to denote a function. I think it's good to have for that purpose. I'm not sure if the parser could effectively parse this as a function declaration without the keyword, but maybe it can. But yeah, this is just to, as I said, this is just to adhere to the zig-like syntax as well, because I'm trying to copy zig-like syntax as much as I can while also having bash. But bash is kind of like the core part of bash is trumping the zig things. So for example, we have the we also have the interpolation like this. Now zig doesn't have interpolation at all, but because of its like low-level nature. But here is just scripting language, so we can do whatever we want. So we have this interpolation here, and of course we have arithmetic. You don't need a special syntax for arithmetic; it just works within the language natively. So this would work as an expression, and you don't need to wrap it with a bunch of parentheses. How do you handle values in the interpreter? NaN boxing? I'm not sure what that is, to be honest. I mean, the values are has a type, so the values can be an integer, a float, an exit code. It can be an execution result. It can be any of those kind of things. So it's a typed value. It can also be a struct type. The idea is later we would extend the type system so you can use type structs. But yeah, I'm not sure if I'm gonna get to that, to be honest, or if I'm gonna just complete the MVP version of this and then leave it be. I'm not sure. We'll see. But it's a really fun project. So maybe I'll like add things here and there when after the MVP as well. Yeah, and then floats, of course. Floats works natively here as well in the language. You don't have to use any kind of external program to make them work, although you can also use an external program like BC, and then just, you know, you can do this if you want. So that also works, but you know, or you can just do it like this, and you don't have to use something like that. But yeah, like basic stuff like this. I'm not sure if we're gonna implement, you know, square roots or math library or anything like that, but it would be interesting because we do have, you know, we have the full force of Zig to be able to do it. So you could just use the Zig implementations of those things and have them exposed as kind of like native functions that we can use. How do you handle values? Oh yeah, sorry. I just read the same thing. By the way, what do you mean by NaN boxing? What could you explain that, please? Yeah, and here's like a word that I didn't know existed before this project: compound assignment, which is the word used for these kinds of expressions or these kinds of operators, plus equals, minus equals, whatever equals, which takes a value, modifies it with a certain kind of operator. So this just works out of the box as well. And this also, I was actually surprised that Bash does support this, although you have to wrap it in double parentheses. And here's like booleans, or yeah, let's just call them booleans because that's simpler right now. Technically, there are no booleans in the language. They're actually exit codes. And so when you run this, you can see that the string version of these are like 1 and 0s, but 1 means false and 0 means true, just like in Bash. And and arrays as well. Here's an array. And I mean, the syntax is a little bit more stable, I would say, than Bash, because I mean, if you're a developer, you look at this and you can understand what's happening. You're defining an array. We have 3 elements. If you were to do this in Bash, and for example, you would include these commas, what's going to happen then? These commas would actually be part of the string. So they would like be part of the element, because I think the array, I'm not even sure how they internally represent the arrays. I'm not sure if it's just a space separated list of words like in one string, or what it is. But it's basically, if you have commas here, it's gonna be included in the string. Even if you have like a string like this and comma, it just feels I don't know, like it doesn't feel consistent, and it accepts weird syntax things that doesn't make sense. So that's part of the reason why I want to, you know, make this. And if you would do this, you would get a compiler error. Except the LSP doesn't work right now, but yeah, anyway. So that's an array, and then you can iterate through the array like this. You get the item out, you can echo each item here. Also, another difference from Zig is that semicolons are banned. And here's an example of multi-source iteration. So we have like an array, and then we have the range here, which has an open end. So it starts at 0 and has no end, which in this case means that it would have the same number of elements as this array here. And then we capture both of these. So item would be the item in the array, I would be the index, and then we echo it out. And this is not possible in Bash to do it exactly like this, but I mean it's pretty close. You can do something like this, but you have to do it in a different way. But it's not that big of a difference. But here I feel like this is more, I don't know, this feels more consistent, is what I'm gonna say. And here's another array. Of course, you can have subs more than 2 sources. You can have any number of sources, and then you get the same number of things here. Nanboxing is a technique used in interpreted languages to allow using bits of a double type to store all values plus type tags. Basically, inside a 64 bits of a double, you get 52 bits to put whatever. Right. Compiler devs put type tags and values that are not double. Does your lang separate double and int, or is it all just number type? It is 2 different. Yeah, it's either an integer or a floating point number, and they are. I don't remember if they are 64-bit right now. I think they are. So it's like a 64-bit integer, 64-bit float. I'm pretty sure. I don't actually remember now, but it's easily changed anyway. But so yeah, they are different, but you can still mix them. You can plus an integer with a float, and it will turn the whole thing into a float. It will first like convert this to a float and then add them together like in Zig. This all the arithmetic stuff happens in the Zig like the compiled interpreter that is compiled with Zig code. And so I mean, I guess you could say nanboxing. It's not exactly, you know, it's each value here is not. They are actually, all the values are the same size, but they would probably be more than 64 bits now, because it depends on, if we look at the value here. So this is a union enum, which is like, well, it's a union, so it will take, each element would take up the same size as the thing that has the most size in here, which would probably be, I don't know. Oh, this is a U size, and okay, probably this one then, because this has like 3 or 4 values. Exit code is a union enum. It has, this is just an enum. This is just U32. Yeah, anyway, so basically let's say each value is like, I don't know, 4 times 64. Let's say 4 times 64 max in size. But it's not really important because, well, it is important in some scenarios, but the thing is, like, this language is not supposed to be super optimized. It's not like, it's not used for its performance. It's used for being able to just launch a bunch of processes and glue them together and do some quick and dirty scripting to solve some temporary workflow or something like that. So that's kind of what it's used for. And if you want to have something that is like actually has performance and stuff, that you wouldn't use bash, you wouldn't use any scripting language, you would use actually a compiled program for that. So that's how I see it. So I'm not like trying to put super much into optimizing the language to make it run super fast. And of course, if it runs too slow, then that's an issue. Like, you don't want it to take too long to just run a simple program. But I think I'm gonna be very tolerant as to how, if it's not performing super well. But of course, it's not gonna be too slow. But it's not gonna be as fast as Bash. I'm just gonna say that straight up. It's not gonna be. I'm not gonna optimize it to the point where it's as fast as Bash, because Bash is very fast, actually. I mean, if you compare it to Runic, it's super fast actually. So it's way faster than I'm actually surprised at how like fast it is, especially like starting up a script. I mean, I guess since it's just running the file as it is, so it would make sense that it's actually super fast. But do you interpret the AST directly in the loop, node by node, or do you generate bytecode? Yeah, no problem. Don't worry. I love when people ask questions. Yeah, so it's parsed into an AST, and then I actually did that first. I interpreted the AST directly first, but then I switched to an intermediate representation, or a bytecode, or whatever you want to call it, another language that it looks like. I can show you here. Looks like this. So this is compiled to this language here. We have a bunch of comments here, but this is compiled to a bunch of instructions, and the reason for that is because it makes it super easy to stop execution or wait for something to complete before continuing. So this is run in a kind of, you could call it like a virtual machine with like its own memory, registers, and instruction counter, stack, and stuff, and also virtual threads, which are like my own threads in this sort of virtual machine. So that is to be able to run like things. I want to use the correct term here. Consecutively or concurrently, concurrently, or in parallel. I'm not sure exactly which term is correct, but it's basically a kind of round robin way of telling which virtual thread's turn it is. So so when you see fork here, it's spawning a new thread into another place to run with a bunch of, these are the standard IO. So we have like standard in, standard out, standard error, and then this is a this is a kind of like a local variable bucket here, or a closure pointer. Yeah, so it's compiled down to this language here, and then this is the language that actually gets interpreted. And the reason, as I said, the reason for that is because a lot of the reason is to be able to stream in pipelines and be able to have basically, if you have a pipeline like this, and then you like, I'm just throwing in a cat to demonstrate here, but basically let's say you have a block that has cat and then, I don't know, grep hello or something like that, and then you pipe that into, so you know, so it can get arbitrarily complex. You can throw in a function call, you can have some kind of other expression, like let's say, you know, let's say we allow strings to also output data or stuff like that. So we need like the thing about the blocks is that the cat, you would have to wait for the cat to or for this expression to complete. Well, okay, this is a good example here. Let me go to blocks. So basically here, in order for this to stream out here, we're running the block, like we're running the block here, but it has to be in a streaming manner. So this we have to wait for echo to output something here, right? Ignore the cat for now. So we're echoing something that should be streamed out to grep at the same time. But then we also want to wait for this to complete and then continue the execution in the block. And the IOR solution was a good way to solve this issue, although the IOR solution is also very complex by itself. So, but this was the reason for me to like switch the implementation from interpreting the AST directly, because I had to implement some kind of mechanism to be able to stop the block execution, but still continue to do other things while this continued. And then I would need some kind of context to keep this, like where are we and stuff like that. Which, I mean, I guess that when I say it like that, it could be possible. But I don't regret going the IR way either, because it made other things possible as well, like debugging, stepping through the instructions. Like we could, oh, this doesn't work anymore. Okay, well, you know, hello, Inco, what? Why do we get this? I'm not sure why we get it, but anyway, here's the debugger. So you can compile and call. Oh, I see. So I have this debug message. That's why that happens. Okay. So you can step through the IOR instructions to see what's going on, and you can inspect everything. You can inspect the pipes. You can inspect the registers, the heap, the stack of this virtual machine from in here. So that would be very hard to do if we just interpreted AST directly, I think. I mean, you could technically implement some kind of context-based, like the problem is you have to walk through the tree in a tree-like structure as well. I guess that's not impossible. But yeah, anyway, it doesn't matter. This was the way that I choose to move forward, and it works, and it's good. It might be too overcomplicated, but whatever. I guess one good thing of this is maybe in the future we could, based on this IR language, you could compile down to native code. So that you could actually make a script that you would compile and get an executable, a native executable. But yeah, I don't know. And the reason for that would basically be execution speed then. But yeah, as I said, that's not the point of this language anyway, so that would seem counterproductive, it feels like. But anyway, yeah. So yeah, that's basically it here. And then, you know, there's some other stuff that I wanted to have in the language as well that I'm not really showing in the MVP because it wasn't really working, or I haven't gotten to that yet. But basically, if you have you can have optional types, error unions was the idea. But we'll see if we get to that. It's not necessary for an MVP, I don't think. But it would be cool if we could get to that. Lowering to native code should be simple in your case if you have types now. Yes, and that's also like, that would be the bonus, I guess. But again, how it depends. I guess it depends on how optimized that is as well, because you wanna. I mean, maybe we could have this IR and then we have another IR, like compiling down to LLVM or something like that. Because compiling down to native code is very, I mean, if you want to do it in a good way, that is very complex as well. Okay, IR function. Yeah, so I'm trying to figure out why this is happening here. Yeah, I can load to an LLVM or and let it optimize. Yeah, exactly. Although there's also the issue with the virtual machine, like, and the virtual threads, because it wouldn't work. You would have to kind of map that to actual threads or something like that. I mean, yeah, that would also be like, how would we run the code? How would we compile it? It's not that simple, also. All right, Penguin, see ya. What do you think of NIM programming language? I think I've looked at it like once or twice, but I haven't actually done anything. I haven't tried it. I don't remember the syntax. And I don't remember what kind of language it is. Let me look it up real quick. So NIM is a statically typed compiled systems programming language. It combines successful concepts from mature languages like Python, Ada, and Modular. Okay, I don't know about Ada or Modular either. Python, of course, I do know, but... I mean, it looks pretty cool. generics. So echo, interesting. You can have parentheses or you can exclude parentheses when calling functions. Or macro. Use NIM's macro system to transform a dense data-centric description of x86 instructions. Okay, I'm not sure if I understand what a macro is. It just looks like a function. Interesting. So I guess it's kind of like the zig comtime, maybe? Universal function call syntax. I don't think I understand what that means. Interesting. Age. Okay, so in the example here it says age is a natural type, which it says that ensures age is positive. That is interesting. Like you have rules based around the actual values of the type, because that is not common at all in programming languages. In fact, the only languages that I've seen has that is the well, funnily enough, TypeScript has it, but those type, what the hell is that? Are they called? COQ is one of the languages. I don't remember what the paradigm is called now, but it basically takes the type system that Haskell has basically and makes it even more abstract. Macros are compile time functions. Okay. Yeah, but I mean, I like comtime stuff. The zig comtime stuff is really nice. It does get, you have to get used to it, but once you get it, it's really nice. And the compiler will tell you if it's working or not. Okay, I'm gonna let's do this to reduce the noise here a little bit. Okay, now we don't even get a function call here, which is interesting, because we know this is a function ref. Compile and call. Why does that not? Keyboard stopped working. There we go. I was like, what the hell? Why can't I press anything? Okay, so compile pipeline. So what I want to check here, so we have like stage expression is this one, look up, and then we compile in the call. So that should be the compile here. So when we compile the call, I want to say more what the call is. file name. Right. Hello. Great. And what is this lookup? Maybe I should look for shallow true. It's not going to be in shallow true though. Wait, what's happening? Oh. Okay, so we find it. We do find it. But it's, I think it's not shallow. If we say shallow true, I think we're not finding it. Not gonna be found. No. So that is one other clue. But we do find it in non-shallow. So if we go here, identifier, and it's not a local binding. So we actually declare a closure variable to be able to get to this value. Okay, I tried zig, but my build of zig broke when after the compiler because the API changed. Yeah. So did you go from 0.13 to 0.14 or something like that? Because I think that was the major update they did with. It's either that or 0.14 to 15, but yeah, they changed the whole zig, build.zig, and also build.zig.zone as well. Please. The keyboard is striking out on me. I'm not sure why. Okay, so I think we're going in here and we're creating a closure variable, and we're looking up the thing. And we should get it from the parent, I believe. Closure value location. Okay. So it's probably because we're saying it's a location then. It's like oh man. But it's a function reference. Really, we should just be able to look it up and use it directly actually. Like if it's a function reference, and it's not mutable. I think we should just return it like this. No, it's not a location, it's a value. Else false, yeah. I mean, really, it's just, you know, we could just do and here, I guess. This feels very stupid here. I just realized. Okay, whatever. It doesn't matter that much. What's happening here? Oh, so let's say that if this is function ref, then we just return the result. Okay, I think it works now. So here's a trick. You do like G debug /D. It will delete all the lines containing that. Okay. There we go. That was it. Hello, hello. Great. But to be honest, sorry, I can't pronounce your name, but you say you tried Zig, but build a Zig broke when you updated the compiler because the API changed. I realized that is like, you know, you get frustrated and you don't want to kind of solve. But actually, that issue is probably not that hard to solve because the change was not really that big. It's basically all the, well, let me show here. The thing they changed was this part. When you have like add executable, you have this root module, and then you create a module, and then you have sources. So this is the only change. Like, I think before these things were on the top level here, and you had like this also, like these things were on the top level. I think the only thing you need to do is wrap them in this to make it work. Other than that, there are some minor changes to, if you let's say you're using the C standard library or something like that, there's a minor change there that you have to change. But other than that, I think most of the things are kind of the same. There's some minor other things as well, but for most like very simple use cases, there's not much that you have to do. It's basically this, that you have to just wrap them in this. If that is the versions that you were looking at, but I don't know. Maybe you were looking at a even earlier version, because there has been other changes along the way as well. I think these things, the B path, that was I think new in 0.13 or I don't know. Anyway, it's not that big of a deal. However, I think more big of a deal was this file here, because here they introduced like a fingerprint that didn't exist before. The name, I'm not sure if that was a string before, but you know, now it's like this weird enum thing. And yeah, actually I think that's basically it. But what I did was basically you just delete. Well, what you do is you look, if you have an independent, if you don't have an dependency, it's super easy, because you just delete this file and you run run init. Make sure to don't maybe overwrite something when you do it, but basically you just run zig init to get a fresh copy of this file, and you can just use it. But anyway, nice. Now this works here. Awesome. Was that something I had written down here? Okay, so actually I would like to look at like function declaration. Maybe this is the last thing we'll do here. So arguments, because that does not work right now. Like if we have, let's say we have an argument here, a string, and we'll put you there. And of course this shouldn't work. Yeah, so we get some weird error here. Actually, this is a runtime error. This actually compiles to something, and then we get some error. So I'm not sure exactly what this compiles to. Let's make a simpler example here. Actually, let's just do this. That should just not do anything. Let's see what this compiles to. I mean, yeah, it doesn't actually. It actually doesn't compile to anything, which makes sense. But the function actually does compile to something here. So we have. I think part of the reason why this doesn't work is because of the closure. Is like this thing here is supposed to be like compiled with a closure context, and that might not be the case how it works right now. Okay, well, this is doing some stuff, and then we have another set as well, set 5. Oh yeah, this is the block, right? Actually, I want to also remove the block. You can technically do this. This is actually a function, and the body is not a block. So the body is just an expression. So it can just be any expression like this, including a block, because a block is just an expression. So you don't have to have a block here. You can have just an expression, is the point. So let's see what this compiles down to, because this very much simplifies this, because I think we don't have a set 5 now. Or maybe we do. Still have a set 5, okay. Or and a 6 as well. Oh yeah, because we have the execution call. What if we just say a plus equals hello? Okay. Binary operator add assign not yet supported. So actually now we get like a compiler error. Actually, interesting. Let's do assign. Do we have assign? I think we have assign. Yeah, okay. So, but it didn't compile, or no? So it didn't compile. I want to see what is the AST here. So we have a function declaration. We have the body is a binary operation. We assign a to hello. Okay. Location while values active. Compiled binary. Sets left source location is right source. Okay. Interesting. So I think it's because of how we compile the parameter here. I'm not even sure if we're declaring this parameter. So what if we say like X? That should be a compiler error. Okay, that doesn't even... That should be like an error when compiling. And my keyboard stopped working again. Echo A. Yeah. I mean, I wanted to avoid that because it's more complex. Maybe we just say A. Okay. Okay, so I think what it's doing, since we're seeing this in the read-only data, it's storing it as a string because it's thinking that this is an executable that it's gonna call. So it's storing it here because, yeah, okay, so this should also be an executable then. Maybe not. Set 4. Yeah, it thinks that it's an executable call, so because A is not declared. Whoops. Compiler. I wish I had fuzzy find on that. I think it kind of has fuzzy find, but if you say something in the wrong order, it just absolutely doesn't find it. I'm not sure if fuzzy find is fuzzy find capable of doing that. I'm not sure. What's happening here? I want to go somewhere. What the hell were we doing? I want to declare these variables. That's right. So compile function declaration. Compile expression, yeah. So before we do that, I want to compile a bunch of parameters, I guess. How would this work? No, we want to declare them as basically like local variables. And how do we pass them in? Is another question. Like in the IR, through the IR. Because we could like create the closure that's gonna populate them. So basically we could do 4 parameters. Oh yeah. Oof. Oh man. What do we do if it's variadic? I actually don't know. Can we have variadic functions right now? I don't think we have support for that. Like user defined. Obviously, executable calls are variadic. Yeah, and then we're using the stack to push a bunch of things, and we are using a number to denote how many we have. Yeah. Okay, well anyway, non-variadic. So it has to be non-variadic because that's the only thing we support. So I'm just gonna assume it's non-variadic, and we get an array of parameters, pointers to parameters. Yeah. So then we do like declare Oh, this would be like a closure variable, I believe. I think. Mutable. Yeah, I think it's a mutable. Identifier should be on here. Oh yeah, we have the binding pattern as well. That is actually okay. Well, if the pattern is not a, so let's do a switch on the pattern. If it's an identifier, we do something. If it's discard, we don't actually do anything. And then we have these two, which are like I'm just gonna say unreachable. Okay. So if we get an identifier, we get the identifier here, and we declare that depth should be 0 for current depth. Mutable is, I guess, true. Type expression. I mean, we can have a type expression. We can. I mean, we do have a type expression. Type annotation. We could put that there. We could also use result type, except we can't. I don't think. Let's just use the type annotation. Fine. Which gives us a location. So we are declaring this. So if we have an identifier with a name, we should get the location. So I don't think we actually care about the location at this point. So I'll just throw that away. We don't want to do anything with this. We just want to declare it so it exists. And then this expression would perhaps refer to this identifier, and then we would be able to find it. Okay, you know what? I'm just gonna say null here. We don't really do much with the types now anyway, so it doesn't really. I'm gonna add it to do, I guess, types. Okay, so now it should be declared, but it's like an empty vessel. And the idea is that when we call the function, we would populate the closure. Yeah, we we create a closure, and then we populate the closure with the parameter values. Yeah. The problem, though, also is that the things that are compiled in here could be referred to things from outside, which then needs to be in the closure as well. And that's something we have to think about. To do closure, so closure bindings, how do we pass them, well, how do we manage them? Known parameters. All right. Let's not worry about that for now. Okay, so I'll copy this part. We'll go down to compile function call. And yeah, we have the arguments here. There are a bunch of expressions. And so, I mean, let's go through the arguments. They should have the same length as declaration. The thing is, we don't even have the parameters here, but I guess we'll just populate based on index here. So we'll go through the arguments. And and that's an expression, so we have to compile it. Arg expression or arg results is going to be compile expression arg. And that gives us a result. Actually, we have to populate this closure. We need like a special closure initialization compilation for functions. Because yeah, this creates a bunch of stuff. Also, the number of arguments would determine so basically I'm just gonna copy this. God damn it. Compile closure initialization for function call. All right, so we need the closure, we need the arguments. Now this would be I mean, I guess we just the problem with passing them as results is that they could all be like, let's say they're using the register like and override each other. So ideally we would want to compile one argument, store it in the closure, then compile the next, store that in the next closure, and so on slot. So ideally we'd want to pass the expressions. The problem is when we compile them, we're compiling them out of order here. Hello, sorry I can't pronounce your name again. How's it going? Okay, you know what? I think I'll add a to-do here. How do we compile these? I will go now. I have to go now, so this is gonna be it for this time. But yeah, we made a bunch of progress. We fixed a bunch of issues, and I feel like we're good on our way to we're very much closer, at least, to the MVP, and we got a good velocity going. But yeah, that's gonna be it for this time. So thank you very much for joining me, and hope you have a nice day. And I'll see you later. Bye bye.